Hello and welcome to our fourth and final installment of describing common TCP/IP based attacks. Denial of service and distributed denial of service based attacks. In my mind, going all the way back to when I first learned about DOS and DDoS attacks, the phrase denial of service, in my opinion, explains the end result, explains what happens when these attacks are pulled off successfully. Well, let me explain. When a denial of service or distributed denial of service is successful, the attack was able to consume all needed resources, CPU, memory, networking, and storage, needed again to successfully respond to valid requests that all other requests are now going to get denied. So the invalid attempts, the invalid requests, maybe for example, sending in a bunch of bogus connection attempts, ends up chewing up the buffers of the destination server. So now the destination server is no longer able to buffer valid requests. Now keep in mind, this denial of service can happen at many different levels of the OSI model with many different protocols. Maybe again, ICMP and a ping of death, or TCP and the three-way handshake, or the session termination, the session reset mechanisms. And then to make all of this even worse, an individual denial of service, maybe coming from one source, that can be amplified even more to have a denial of service style of an attack come from multiple different sources and what's referred to as a distributed denial of service. And again, some of the ways, the mechanisms that these styles of attacks are executed, are pulled off, if you will, is in what's referred to as reflection and amplification. And we're going to give you a couple of examples of these as we continue forward. So a reflection would be where the system being attacked is actually not going to be the true source or the true responding system, and instead the true attack is going to be reflected onto some other spoofed source address. And then we can amplify that even more by having the destination of the attack be responded to by a large number of different sources. So again, the victim, the actual server or service that we want to compromise, could be on the receiving end of a whole bunch of other systems responding to it, again, amplifying that style of an attack. Folks, I can't speak for you, but in my opinion, a picture is worth 1,000 words. So let's take a look at a couple of these pictures to explain this better. So for example, the attacker is going to do an ICMP echo request, which again, we know is the first part of a ping. But please understand it's coming from a 10.115 address. The attacker is not 10.115. So right there, that's going to be the reflection. And it's going to a broadcast, maybe the 10.11255, the broadcast for that subnet. Right there, when the entire subnet receives the ping request, and then the entire subnet ends up doing a response to the ping, that is the amplification, the example of the amplification. Continuing on with spoofing attacks, keeping in mind that once again, spoofing is simply claiming to be an address or a system that you are not. So let me be a little bit more vague about that. I'm going to say claiming to be a system, because as you can see here from these three different types of spoofing attacks, and I'm going to jump around a little bit just because I'm really an OSI model guy. So I think of the bottom and work my way up the OSI model. So MAC address spoofing, claiming to be, for example, the MAC address of the default gateway. And keep in mind, a lot of people might think, well, why would I ever want to spoof a MAC address, spoof a layer 2 address? Well, keep in mind when we are going first through an access point on wireless, first through a switch on a wired connection, we can take advantage of that device by spoofing the very address that that device uses. Again, a MAC address. Then working our way on up to layer 3 with IP address spoofing, maybe again, as we talked about a moment ago, by way of poisoning an ARP table, or even by compromising entries inside of a routing table. And then finishing up with the bottom example of a spoofing attack with application or services, just once again working my way on up the OSI model, being more of an infrastructure person. This was an example we gave a moment ago, where we have a spoofed an invalid or maybe even compromised DHCP server that is giving out to real clients, enterprise users, giving out bogus or compromised addresses that might be, let's say, a valid IP address and valid mask, but the default gateway given out by the spoofed DHCP server is going to forward all of the unknowing client's traffic to the attacker's system so it can gather traffic, it can gather maybe login credentials. Here they're showing you an example, a diagram, trying to give a little bit more details, a little bit more meat on the bone for spoofing attacks, with this first one again being spoofing an address. So once again, we're trying to communicate between the source and destination, but what actually ends up happening is that destination address is going to be spoofed, and the session information, the session traffic is going to be redirected. Now, keep in mind, that's only one of many different examples where we were spoofing the destination address. Keep in mind, the source address can also be spoofed. It truly is just a matter of where is the attacker coming from, or what style of an attack is the attacker trying to perpetrate. A little bit more detail again into some DHCP style attacks. We've already gone over a couple of times with the DHCP server spoofing. One more time, high level, the attacker with a DHCP server of their own, giving out, in my opinion, from my experience, valid IP addresses for the client and the subnet mask, but again, giving out an invalid and attacker-controlled default gateway and DNS address. Also, from the attacker-controlled default gateway, the attacker can control the forwarding of traffic, and the attacker-controlled DNS server, the attacker can control what IP addresses are given for DNS name requests. Now, a new one here in this example is going to be DHCP starvation. So the scenario is there is no attacker controlled DHCP server. What happens instead is kind of flip the scenario around. We have the attacker with, let's say, a compromised system or multiple compromised systems sending a bunch of DHCP client requests to the DHCP server, exhausting is the word I was looking for a moment ago, but consuming all of the valid addresses within inside of the DHCP range, or what is more classically known as a DHCP scope. So in my opinion, the DHCP starvation is a great example of a denial of service on a DHCP server. So they're giving us a little bit more details here, putting some of the wording from a moment ago on top of a diagram where across the top we have ourselves an attacker-controlled DHCP server, while on the bottom left we have a legitimate enterprise-provided DHCP server. Folks, in my opinion, one of the very, very important things to understand here as to how DHCP attacks are able to be pulled off, or fancy word, perpetrated, is understanding that the client sends out a DHCP request, which is a very, very fancy way of saying a broadcast request. So this attack can very, very easily be pulled off by the attacker's DHCP server simply being on the same subnet and replying before the enterprise DHCP server is able to respond. Now, one of the really, really cool things here about this is we have many features. For example, our DHCP snooping, our dynamic ARP inspection, and a few other features that we will talk about later throughout this series that will enable the infrastructure, in my opinion, philosophizing here, the infrastructure being the first point of connection will enable the infrastructure to also be the first point of protection and control.